that when you reach out for the glass, you're making a choice to pick it up. And I do it too. I sort of felt like I just picked that glass up because I made a choice, but fundamentally I don't think that I did. But putting that to aside, yes, we feel we have control, we act as though we have control, and then Einstein's quote comes into play, because once you have control, you can shape the future, and you can shape the future according to distinct values. And yeah, I think that is the only way that we humans can live, in this until we evolve to some other form. And sure, there is no way to look to science to tell us how they shape things from some sense of value to it.
Okay. All right. Let's talk about Higgs boson.
Free will?
I'm sure they're related somehow too. I want you to, you wrote an article for the Smithsonian magazine last summer, and I'd like you to tell the parable of the fish that you said physicists tell each other.
Oh, yeah, right. So, let me just motivate it first. So, the idea of this Higgs particle, Higgs boson, and most people have probably heard about it or read something about it, suggests now from experimental data that a theoretical idea that was pure mathematics when it was introduced might be correct, which is that the universe may be filled with an invisible substance called the Higgs field, and as particles try to burrow through this environment, they feel a kind of resistance, which is where their heft or their mass comes from. But we have to accept this strange idea that there is this invisible substance that is all around us.
And I love the idea that mass is interactive.
That's right.
Right
So
there.
mass comes from an interaction. Exactly right. It's not something that is just sort of imbued from the get-go or from the outside. Now, a parable that gives us some sense of how you can take that very strange story and make it seem less strange is to just think of fish in the ocean or fish in a fish tank, right? They're swimming around and they're really not aware that there is a part of the universe that's not filled with this watery substance. In fact, this water is so familiar to them that that is emptiness. That is their universe. So there you have some beings that are living within an environment that is suffused with essentially an invisible something, water, and yet, because they're in it all the time, they don't know it. We are in the Higgs field all the time. We experience our interaction with it all the time, and that's why we don't even know it. And that's why it takes these dedicated experiments that clue us into something which at some level should be obvious.
So this is what I think I understood from reading your article, and in a way that all the articles I've read about Higgs boson have not quite helped me grasp that that what the Large Hadron Collider did is that it was able to jiggle this field enough that, to cause a tiny droplet to spill off,
Yes.
and then provide some kind of evidence
Yes.
that there was
that's
something
right.
to this theory.
That's right. So this machine slams protons together near the speed of light, and through that collision, the ambient Higgs field, like water, you get two submarines crashing into each other. The field gets jostled, and if you jostle it the right way, which happens about 1 in every trillion collisions, you can flick off a little speck of the field, which is the Higgs particle that we believe is found. So, got it right from the article. Perfect.
And that this is a new form of matter.
Yes, that needs to really be emphasized. So, the discovery of a new particle is exciting. The discovery of a particle that has been predicted for 4 decades is exciting. But it's even more exciting because there has never been a particle like this before. So, just to quickly tell you why, we've known for a long time that the familiar particles like electrons and quarks, protons and neutrons, they're not even fundamental, but they all share the property that they spin around, sort of like a top. There's a quantum mechanical twist to this, but it's not such a bad image to envision that they're spinning around like a top. The Higgs particle is the only fundamental particle that we have that doesn't spin around. It's a spinless species of particle. Now that may sound kind of esoteric, who really cares whether it spins or not? The reason why that's very exciting to us, we have made use in our equations of spinless particles, hypothetical ones, for decades. They play a role in our understanding of the Big Bang.
But you couldn't be sure, you couldn't prove they existed.
You couldn't even know that even that species was real.
Right.
So now we found one species that has this spinless property, which gives us a little bit more hope that the other versions that we've used in our equations might be true as well.
that's really interesting. And so explain something else to me. You, in this context of the Higgs field, you talk about this as being a manifestation of nature's version of nature versus nurture.
I do recall saying that. The funny thing is, I'm sitting here now, and it has such a nice ring to it. I do not know what the heck I was referring to any longer. It was like last summer. Can you tell me what I meant when I said that?
Allow me.
And let me just even tell you, I remember the editor at Smithsonian said, it sounds nice, but we don't really get it. I was like, it's so obvious what it means. And now I'm sitting here, I can't remember what I was referring to.
Okay, so what you're talking about.
Yeah.
Is that there's an interplay between these fundamental laws, and there's also an environmental factor.
Oh yeah, there we go. Thank you.
You can call me anytime you want to understand your.
Yeah, thank you. No, that's a very good point. I couldn't have said it better myself. Yeah, that's right. So you've got the fundamental laws of nature, which we think of as nature's way of grabbing hold of the universe and causing it to evolve in certain ways, according to those laws. But there's also a feature of the things that we experience that is just out there. It's almost a historical happenstance that in our realm, space is filled with this field, and we also experience the effects of it. So it's the fundamental laws together with the environment that really come together to shape our experience, even from our fundamental understanding of the Higgs field.
Mm-hmm. So, what is the relationship between the quest to understand what dark energy and dark matter are and the Higgs boson field?
Well, that's a really good question, especially on the dark energy front, because there were some wonderful observations back in the 1990s that turned our understanding of cosmology upside down. Because we've known since 1929 that the universe is expanding, but everybody thought that the expansion was slowing down over time because basically gravity pulls things together. So the gravity of each galaxy would be tugging on each other, slowing the cosmic expansion. But these observations showed surprisingly that the expansion is speeding up over time. They won the Nobel Prize for this observation.
Right, that's one of those observations that completely turned a lot of givens on it.
That's right. I mean, everybody thought what they were doing was just confirming what everybody knew and putting some quantitative detail to the rate of cosmic slowdown. But they found that it was cosmic speed up, not slow down. So that left us theorists with the puzzle to explain why it is that the universe is speeding up in its expansion. And the best answer we have today is that space is filled with another uniform, invisible something called dark energy. It's very similar in a sense to the Higgs field, except what this dark energy does is it gives rise to a repulsive gravitational force, something that comes right out of Einstein's mathematics.
Mm-hmm.
Gravity does not only have to be attractive. Let me emphasize, does not only have to be attractive, it can be repulsive. If the source of the gravity is not the sun or the earth or the moon, but this dark energy filling space. And that is our best explanation for what's pushing. Repulsive gravity is pushing all the galaxies apart. Let me just say, now that we found that there is another invisible something filling space, the Higgs field, it doesn't feel so far-fetched to imagine this dark energy might be the real explanation.
But the Higgs field is not dark energy.
No, the scales involved, the energy scales involved are not right for it to literally be the dark energy, but the dark energy shares many features with this Higgs field.
All right. So as you say, it points you to it confirms this sense that that dark energy could be what you're perceiving.
That's right. That's right.
Okay. So let's come back to these existential questions again. You quote Einstein a lot. You also quote Camus a fair amount. And
yeah, they're both dead. They can't really come back and say,
yeah.
don't use my words that way. So it's kind of a safe thing to do.
But you seem to have been quite taken when you read Camus' writings. Was that book that you pulled down from the top shelf of your father's?
No, it was. My dad had, a very varied library that sort of spanned a whole variety of subjects, and one of the books was a Camus book, Mythicists.
Yeah.
Yeah, and it's kind of an amazing thing that in the opening sentences, Camus talks about how knowledge of certain features of the world, like whether or not there are three dimensions, this is,
Did he say that?
Yeah,
Oh.
and whether or not the brain has this or that many distinct processes that are going on. And he basically listed a variety of scientific questions, and he said all of those are secondary, because the only true philosophical question, he said, was that of suicide. Now, for a young kid,
The choice to live.
the choice to live or die, that's the only question that ultimately matters. And when I read that, I was quite young, and it was almost kind of this shocking sentence to read, but it also seemed to me right. I mean, that is the only question that ultimately matters to the individual. But then as I got older, I began to see things a little bit differently. Because to me, the question of whether life is worth living, to me, is intimately dependent upon what life is and what reality is. Because ultimately your life is lived within reality. So to me, the question of whether there are 3 dimensions or 10 dimensions is so captivating that it does impact my desire to live. And again, I don't mean that in some melodramatic sense. If tomorrow we establish that there are 3 dimensions of space, I'm not going to sort of jump off the Empire State Building. But what I mean is that these questions about the rock-bottom structure of reality do inform my life. They are not esoteric scientific issues that I leave in the office when I go home at night. And it's that distinction that ultimately struck me as not as accurate as it might be in his writing.
Mhm. And for you, as for many scientists, I think, science, is essential to the fullness of understanding of humanity, just as literature and art and music are.
Yeah, absolutely right. I mean, we have these arbitrary distinctions and cordoning off of science in particular. It typically sits at the outskirts of culture, and we sort of wheel it in whenever we have a problem. We wheel it in when we love the technological advances that it gives rise to, but still science is generally pushed off to the side relative to those things that really matter to a full life. The examples that you give, like music or art or theater or literature, those are the things that really speak to our humanity. And science is somehow off there for the scientists. And I think that is tragic, because science deserves to be right smack in the center of culture, because it is our quest to understand who we are and how we fit into the big picture. Just as great poetry is, just as great literature is. So it's not this separate activity. It's all part of the human swirl to make sense of a fundamentally senseless position that we find ourselves in, right? We're thrust into this world on this rock that's orbiting a nondescript star in the outskirts of an ordinary galaxy. Wow! I mean, can you imagine being thrust into a more bizarre and strange reality than that? And what we've been doing for thousands of years is just trying to, piece by piece, get some understanding of where we came from, where the universe came from, and where it's all going. So to me, that is not distinct from what the poet does, or what the philosopher does, or what the great writer does, or the composer does. They just do it in a different language.
I was very struck by the letter you received from a soldier in Iraq, and the real comfort and meaning that he was able to take. I mean, that's one of those juxtapositions, right, between what the mathematics is telling you and this person in one of these very dark, gritty experiences of life.
Yeah, that's absolutely right. I was at first surprised myself to receive that letter, just to say what it was. It was a soldier who was writing basically from the battlefield and saying that out there in the sort of dusty, difficult environment of Baghdad, he had one of my books with him, and he would dive into the book whenever he could, because, as he wrote to me, he said it kind of gave him the ability to rise above all of the distressing and dangerous and frightening aspects of the local environment of wartime and lift himself into this realm of big questions where he could just feel like all of the difficulty and all the tragedy around him was put in context by virtue of seeing the larger picture of reality. And I think that is what science can do for you. It really can allow you to lift yourself out of the everyday. If that everyday is dangerous, if that everyday is somehow unpleasant, even if that everyday is wondrous, but it can allow you to lift above it and experience reality in a different way.
So I was recently speaking, I think it was a religious setting, or it was a university setting, and somebody asked me, a professor of the humanities, talked about his concern that there's this new way of emphasizing the importance of science over the humanities, and one of the reactions I had is that I feel like sometimes when this is brought up culturally in terms of education and preparing people for the future, it's leaving out this sense of wonder and of science's place in the deepest questions, the greatest mystery and explanation of reality and who we are.
You're right. The urgency to fund STEM education largely comes from this fear of America falling behind, of America not being prepared.
Right.
And sure, I mean, that's a good motivation, but it certainly doesn't tell the full story by any means, because we who go into science generally don't do it in order that America will be prepared for the future, right? We go into it because we're captivated by the idea.
Yeah.
And I think that's how you get kids excited about this. You look at any of the times when a government is willing to spend significantly on some undertaking, it's largely because they're afraid. They're afraid that they're going to be taken over. They're afraid that somehow they're going to fall behind. And it's unfortunate that fear drives so much activity of that sort, when the reality of those in the field are not driven by fear, they're driven just by the excitement of discovery. And if a kid can get that aspect, get that perspective of science, it's a very different reason, a much better motivation for pushing forward.
And that understanding of science suggests a really interesting interplay between science and the humanities, too.
Yeah, for sure.
It opens up your imagination about what that looks like.
That's right, because, when you recognize that these big questions of the ages that have, for a long time, been sort of viewed as part of the philosopher's archive or the poet's inspiration, now science is starting to give us some insight. Real insight into how the universe began, real insight into what things will be like in the far future. When you recognize that there are Earth-like planets out there, right? How does that not change your perspective on reality? So all of that needs to be folded in. And I am enormously impressed that there are so many artists, so many filmmakers that contact other scientists because they want to be inspired by these ideas. Mm-hmm. They want to understand them at a level where they can begin to infuse their own activities with the knowledge that science is revealing.
Yeah, and I would even say that in the 21st century, things that are happening in physics, things that are happening in neuroscience, are actually speaking to the questions that had been the domain of philosophy and theology and spiritual traditions.
Yeah, that's absolutely right.
Do you, I wonder, are there discussions that are happening even like in your life or at Columbia across disciplines that you think wouldn't have happened 20 years ago?
Well, it is always hard to break out of, the institutional divisions between subjects, and that is no different here at Columbia than I think in many other places. But sure, one of the things that we do here is we have a rare opportunity. There's a course that we teach to freshmen in which scientists from a whole variety of different disciplines come together to try to give them some feel for the range of scientific exploration. So that sparks certain kinds of conversations that otherwise wouldn't happen. But it is certainly the case that we are far from some kind of ideal where the various disciplines just can play off of each other freely. It's a wonderful image. It's very hard to put into practice.
So I'd like to come back to this, the hiddenness again. I think it's perplexing. And there's a sense in which if you know, even if we accept this and respect it, that our senses mislead us about the nature of reality, that kind of thwarts the ability of ordinary human beings to internalize the lessons of science.
No, you just gotta learn math.
I mean, you said that assessing life through the lens of everyday experience, and you really meant their life as in the meaning, the ultimate, what reality is like gazing at a Van Gogh through the lens of an empty Coke bottle.
Yeah, right. I think that. Hey, no, I think that's not a bad metaphor.
Okay, but well,
There are better metaphors. But yeah, no, I think it's the thing that we have to recognize is that, you know, since the 1800s, we've learned that lesson. I mean, I think it was Faraday when Faraday proposed. I think I've got my history right. That there were, you know, magnetic fields, electromagnetic fields filling space, right? How does a magnet work? I mean, take these two pieces of metal together, they don't touch, but they can push against each other. How are they doing that? And his proposal that there's an invisible field that surrounds the magnet, people thought he was crazy, right? Now we sort of take it second nature, right? We sprinkle iron filings in the vicinity of the magnet. We can actually see the field by virtue of how those filings trace out these interesting lines of magnetic field lines. So we have, over time, been willing to accept things that are invisible, but initially seemed crazy when they were introduced. And when you recognize, and I think perhaps this brings it home the best, that quantum mechanics, it talks about a reality that is largely invisible, that involves probability waves propagating through environments. And yet when we use the mathematics of quantum mechanics to predict features of the world that we can measure, like the magnetic properties of a particle like an electron, we can do a calculation using quantum mechanics to 10 decimal places, 2.13596, 10 decimal places. That's the result of a mathematical calculation. We then go out and measure the magnetic properties, and we find that digit by digit by digit, 10 decimal places long, the observation agrees with our scribbles on a piece of paper. How can you not be in awe of that? And how can you not be convinced that that is revealing some deep truth about reality that you simply are not privy to with your eyes or your hands or your ears? There's no sense that allows us to directly experience the quantum world, but the mathematics allows us to understand it and make predictions that agree with observation. That's a very powerful story.
Mm-hmm. There's also a lot, at least right now, that is the substance of our day that can't be measured. I mean, do you think that at some point something like consciousness or love might be measured?
How did I know you were going to love? And I was saying, is she going to the love question? And I was right. I do. You know, I don't mean to sort of sound like, you know, some hard science. I hope I don't come across like this. It's not how I am. But I do strongly believe, based on what we know today, and that could change when we have a deeper understanding tomorrow, that all of consciousness, all of our emotions, is nothing but some physical process playing out inside this messy gray blob inside of our head. That to me does not diminish consciousness. It does not diminish the experience of love or happiness or sadness or any of those things that make us human. But it does, I think, reveal the true underlying process responsible for those sensations. It's nothing but certain things happening inside this gray brain of ours, and one day we will understand it well enough to map it out in detail.
In about 10 minutes, I'm going to open this up to questions. So just following along these lines. All right, so let's take very ordinary experience we think we have of time.
Yes.
Right? It's just, it is, again, the substance and structure of our day as we tell us the story of Newton's clockwork world. 100 years after Einstein told us, explained that time is relative, we cannot internalize that, right? He said it's a stubbornly persistent illusion. We have this stubbornly persistent illusion that our senses constantly reinforce that time is an arrow, moves forward, it's linear, it's past, present, and future.
Yeah.
We cannot internalize that. But you live with, you have your hands in this understanding of reality all the time. So how do you experience, are you able to experience time differently in your human sense because of what you know as a scientist?
I can, as I was saying before, I can encourage myself to cut away experience and try my best to experience what I know to be true, but that's a far cry from actually living the truth. So if you ask me, is the past gone? Yes, I would answer yes to that. You know, is my father dead? Is he gone? Yes, that is how I answer as a human being. And, you know, when I look at the laws of physics and I take in the Einsteinian perspective, I can try to recognize that, as Einstein taught us, the past is really not gone. It is as real as the present or the future. You just have to recognize that different observers, different individuals in the universe moving at different speeds, slice up reality in different ways. What's past for me could be future for somebody else, so in that sense, it is as real. It could be the present for them too, so it's as real as the present is for me. So yes, I know that stuff. I teach it. I make my students answer problems and take exams on it. But if you ask me, have I been able to really stitch it into the fabric of my own experience of life? No, it's very hard. It's very hard to overcome the day-to-day features of the world as our senses allow us to experience them.
When you say every once in a while you're able to stop, and I mean, just kind of break that down for me, like in a moment where you really make this attempt.
Yeah, so I mean, there are times I'll walk down Broadway, heading to get milk at West Side Market, as many in this room know that have done, and, you know, I'll pass somebody, and I will imagine how my watch is ticking off time at a different rate from their watch, and how as I look at their watch, I see time ticking off slowly. They look at my watch and see my watch ticking off time slowly. Sure, I play that game, and it's sort of a fun thing to try to put yourself into the true bubble of reality as physics has described it. But it's not as though there's any intuition, deep intuition associated with that, right? If you were to wake me up at 2 o'clock in the morning and sort of rouse me from a deep sleep and ask me any of the real questions about time, I'd answer as a human being. I wouldn't answer, when I say that, I'd answer based upon the intuition of an ordinary human being. I wouldn't answer based upon the knowledge of somebody who has studied the physics.
So I think this gets back for me to not questioning the value, and that would be absurd, but how do we reconcile? It's a puzzle. It's a puzzle.
Well, maybe it's one that we don't really need to reconcile. I think as long as you're willing to live through life and say, the vast majority of things I am experiencing are a lie. They are misleading. It's an interesting lie, and it's a useful one, because if I don't tell myself that lie, I have trouble existing in a social environment with other human beings, right? It's very hard to step outside of the things that everybody implicitly agrees on constitute reality. But if you are able and willing to tell yourself, okay, it's a lie, it's fake, but I'm going to do it anyway, because that's the only way I can live, as long as you can then turn your attention, at least in your mind, to the true reality, I don't think it's such a bad thing to have that parallel experience happening. And to me, that's basically what I do.
It doesn't feel elegant to me.
Well, yes, I mean, I can envision that one day we evolve to a point where maybe we are actually experiencing life at fast speed or life at strong gravitational potential. And then we would find our intuition shifting toward the true reality that comes into play there. But at low speeds and low gravitational potential, the Newtonian worldview does a fantastically good job of describing how the world operates, and that's how our intuition evolved, and that's what we are stuck with.
Okay, let's take some questions for a few minutes, and then we'll come back and close up here. I believe there's what do people do? Just, here's a microphone.
What's the best evidence we have for string theory right now? Some of the best and most credible evidence that you know of we have for string theory.
Yeah, so the evidence is string theory is right. Good. So other questions that So the quick answer to your question is absolutely nothing. So string theory is a completely mathematical undertaking, and at the moment there is no experiment that we can point to which you say there is the evidence for this idea. For that reason, string theory really should be called the string hypothesis. Theory in science is a very specific meaning, and string theory does not rise to that level as yet. Now, having said that, let me just point out that we have tested quantum mechanics. We know it's part of the way the world works. We've tested general relativity. We know it's part of the way the world works. We believe the universe has got to have a consistent description of the laws of physics. And without string theory, quantum mechanics and general relativity, or theory of gravity, they do not come together in a consistent way. So string theory is solving, or purporting to solve, an absolutely vital problem, to put gravity and quantum mechanics into one uniform package. So there's reason to believe that there has to be a theory that finally unites them together, and string theory is the theory that we have on the table. Additionally, let me just mention, it could have been the case that when you put gravity and quantum mechanics together, there was a theory on the table that had no resemblance to any of the other ideas that have been developed over the course of 30 or 40 or 50 years. The amazing thing is, within string theory, you find, for instance, the Higgs field, or something that can be the Higgs field. You find that you can incorporate electrons and quarks and neutrinos. You find that you can incorporate the gauge symmetries that give rise to the weak force and the strong nuclear force. So all of these ideas that have been slowly, systematically developed over the 20th century, they all find a natural home within string theory, which to boot puts together gravity and quantum mechanics. So there are many reasons to be excited about the theory, many reasons to have enough impetus to study it, but we've not made contact with experiment as yet.
Earlier you mentioned the universe possibly being encoded on some sort of boundary, and you gave the analogy of a two-dimensional boundary to a three-dimensional object. I was wondering what the actual dimensions in the mathematics are.
So it really
This will
could...
be accessible to the general public radio audience.
Yeah, so there are various versions of this holographic idea, and the simplest incarnation would imagine that there is this two-dimensional surface surrounding our three-dimensional space. Now, there are more exotic versions that we have confidence in that at least make mathematical sense from string theory, where you're talking about a 10-dimensional space which has a 5-dimensional part that has time in it, and an additional 5-dimensional piece which takes the form of a sphere, and in that environment you can also play this holographic game. So there are many mathematical incarnations of this idea, some of which we understand really well, and whether or not they're relevant to reality as we know it is still unclear. Although I should say there are certain string theorists who are absolutely certain that this is the right way of describing the universe. So we'll see how it plays out.
If there's this idea of this base of information, of which everything else is a projection of that, doesn't that, and I guess this is a pedestrian question, but doesn't that raise the question of the source of this information? I mean, one of the analogies you use, it's like we're the skyscraper to the architect's blueprint, but so what is the source of that blueprint?
Right, it's hard to answer that question, and we don't purport to have an answer. It could be that when we understand how these ideas fit into cosmology, the study of the evolution of the entire universe, that we may have a story that if you begin with a universe in this and this state, then it evolves to a form where you have this information encoded on these boundaries, and it all makes sense. Now, again, you could say, well, where does the initial universe,
Yeah,
where does the initial nugget
this
come
could
from?
be science answering the question of, is there a God?
That's right, although, there are, at least in principle, ways to answer these questions that don't need to invoke anything that stands outside the laws of physics. So
Mhm.
God, to me, is one of a variety of proposals that people have put forward of things which would stand outside the laws of physics. Because you could imagine, at least in principle, and again, I underscore in principle, maybe one day we will find that the reason the universe exists is because it would be logically inconsistent for it not to exist. That the laws of physics are so tight, so taut, that there is no possibility, no counterfactual makes sense. There had to be a universe because the laws of physics could not allow there not to be a universe. And that, to me, would be pretty convincing if we ever got to that point. So there wouldn't need to be something outside to make it exist. Logical consistency alone would demand it.
I have both a question and I'm looking for some advice as to how to frame the question. So colleagues and I are talking about the revelations that the NSA has been spying on almost everyone. And I asked the question, or I proposed the idea that that observation is potentially changing the results, right? The result of that observation could change solutions for privacy, controls, and all of that. So your parallel universe idea, I'm wondering if it partly answers my question that there is no privacy because the observation spins off multiple solutions, multiple results, but I don't know how to frame the entire question.
Yeah, that's pretty heavy. Yeah, I don't know how to frame it either, because, again, while it's understandable and even laudable to try to link together some of the ideas that emerge from fundamental physics
Right,
to
so
the experience of everyday
This
life.
is the idea that, this is the assertion of, this is the new kind of discovery, right? In your lifetime, that in a way that there's no such thing as subjectivity, that the observer also is a participant.
That's right. So that's actually a little bit before my lifetime. So this is back sort of in the 20s and 30s,
Okay.
when people were struggling to understand quantum mechanics. One of the ideas that came to the fore in trying to address a question that we discussed briefly, which is how do you get a definite outcome from a theory that has probabilities built into it? And one of the thoughts that came forward was maybe it is the observer, him or herself, that their active observation is vital to causing a unique reality to emerge from this fuzzy mathematics of probabilities. And I think over time, people have recognized that that was an overemphasis on observer, in the sense that it's not a human being that's vital to the story. It could be an amoeba, it could be a dog, it could be a computer that does the observation. It's just environmental interaction with a system that's being studied. And yes, it is the case that if quantum theory is correct, and we believe it is, that even the observational device, whether it's a human or a computer or an amoeba, when it comes into contact with the system it's studying, you have quantum systems coming together, intermingling, and you need to use quantum mechanics to describe the whole thing. So we're still struggling to really understand what that means, but I would say it has de-emphasized that earlier idea that there is this pristine break between the observer and the observed. And it's only when the observer comes on the scene that new notions that disambiguate the probabilistic outcomes occur. Most people don't think that way any longer.
Mm-hmm. And I think this question was analogizing that with
Exactly.
a real world in the news
Exactly right. Yes.
dynamic.
Thank you for all your work and the way it's informing my guild. I'm a theologian. So I have two questions, really. I either did not understand or am not convinced or persuaded by your conversation about free will. Because it sounds as if your proposal situates us in a very deterministic universe, and that we are simply, in some sense, almost robots acting out of these general laws, and that there's no novelty within this very, very complex and creative entity that we are as conscious beings. So that's my first.
Yes, it is hard to accept. But I wouldn't go as far as to say there's no novelty. You know, when you bring complex systems together, even when they're governed by deterministic laws of physics, which, as we understand, some people say, well, what about quantum mechanics? Doesn't that sort of take away the determinism? No, it doesn't at all, not at our current level of understanding. So the mathematical laws that Schrodinger wrote down for the quantum evolution are as deterministic as the laws that Newton wrote down. They determine probabilities, but there's no place in those laws for anything other than deterministic evolution. Now you can get novelty because when you bring complex things together, they can commingle and interact in ways that might be surprising. And I'm using human language to describe it. Sure, it comes right out of the equations, but it still can be novel by any human barometer. So I wouldn't say that novelty goes away, but yes, free will may go away.
So free will meaning choice. There's no such thing as choice.
That's
I do
right.
not choose to love. I do not choose to extend myself. I don't choose to live. To get back to
Well, it all
Kevin.
depends on what you mean by choose. So if by choose you mean that you could have done otherwise, then I would say yes. But I would say that you need to redefine the meaning of the word choose. Choose is the sensation of choosing. Now, it is the fact that the laws of physics were just playing themselves out, and that is fundamentally why you did what you did. But to choose is to have the sensation of making that choice. And we all have that sensation, and that is a definition which I think works well. It does require a little bit of rejiggering of your intuition to recognize that it may be the case that the laws of physics that are behind the scenes doing it all. But yes, that sensation of choice is real. And that's what we should redefine free will to mean. Free will is the sensation of making the choice, even though behind the scenes the laws of physics were pulling the string.
Thank you. I'm still not persuaded. My second question, though, has to do with positing the divine reality, which, let's use the God word, as somewhere outside, above, and beyond this physical universe, or this universe that is manifesting itself through these physical laws, which you and your scientific cohort are perceiving and questing for. Why do you keep positing it above and beyond, since we in the theological guild are not doing that anymore?
Well, if you use the word God to mean a being that is composed of the same stuff that we see in the world around us, governed by the same laws that stuff is governed by, then God is a perfectly coherent and sensible idea. And if that's what you mean by it, then we're talking the same language. But if you mean what traditionally is meant by God, which is a being that can intercede, that can cause things to happen that are not governed by the laws of physics, then we are talking different languages. And I should say, I'm not saying that that idea is wrong. It may be right. It may be that God is behind it all. Maybe God set it all up, and there's some variations of these ideas where God sits back and lets it all play itself out. And that could well be what's going on. What I really mean to say is not that the idea is wrong, but as a scientist, I find it profoundly uninteresting. Because it gives me no new insight into any of the deep questions that we've been talking about here. Doesn't help me calculate anything, doesn't help me gain some insight into these big mysteries. It simply takes one mystery and uses another 3-letter word to relabel that mystery. And that is why I don't find it interesting. Not that it's wrong, I don't find it interesting.
And that's why I think the dialogue between religion and science is so urgent and interesting, because...
Oh, but I should point out, let me just point
world-
out, I find the dialogue between science and religion exceedingly interesting, because to me, It's a conversation that really speaks to who we are and where we've been and our desire to understand and the stories we tell ourselves en route to trying to get deep understanding. I find that profoundly interesting. When I said it's uninteresting, I meant in terms of the questions of physics. It doesn't allow me to gain any progress in those questions.
Okay, thank you. No, I'm sorry, we have a few more questions. Okay, yeah, thank you, yeah. Try to be succinct.
Thank you both for coming to speak with us today. My question is actually in regards to a tension that I picked up on in the conversation regarding the interaction and overlap between science and the humanities. On the one hand, I agree with you, your analysis, Dr. Greene, in that the sciences and the humanities are fundamentally interconnected and are really just two different sides of the same coin. But I noticed, and I apologize if I misquote you, Krista, that when you were asking Dr. Greene to explicate his views, you said coming from a non-scientific or non-science perspective. And so that seems at odds to me, because if the sciences and humanities are fundamentally the same, how can there be such a thing as a non-science perspective? I mean, speaking from personal experience, I'm an undergraduate here, and I took the course to which you referred, Frontiers of Science, and it seemed to me like there was a knowledge barrier. Because I'm not a science major, I don't have a particularly strong science background. And so I'm just wondering if you could elaborate on your personal perspective.
So I said from a non-scientific perspective?
No,
So maybe Krista should address your question.
Let's take another question. Let's just. I think we should keep moving.
Let me give you one.
Yeah.
So one quick answer is, I think there will come a time when we won't draw these sharp distinctions
Right.
between these different approaches. So it won't be, for instance, that there's some film that has some science in it. It'll be a film, and of course, some films will have some science in it. It's not that we have a theater piece or a piece of literature that has some science at its core. It was just natural, because that's the part of human experience that should be woven into these artistic, humanistic disciplines. So I think that time will come.
A question that may well be very related. Dr. Greene, you speak quite beautifully of this mad mathematical reality that undergirds our understanding of our experience. We get up to these deep questions. And the way you describe it makes it sound like it's realer than reality as we experience it. And I'm on board with that as much as a layperson can be listening to a translation. But my question is, as the answers to these deep questions become more and more counterintuitive, how useful or how real is any of this as it becomes accessible only to people who can understand these sorts of wonderful mathematical answers?
Well, again, things that are complex to us, 100 years from now, we'll be teaching it in second grade. So we see this all the time. And so I don't think we can judge things by a snapshot of a moment in time as to things that we're comfortable with and things that we're less comfortable with. But I think it's important to recognize that, as we were discussing before, even the abstract, esoteric ideas of quantum mechanics, you are carrying around quantum mechanics in your pocket if you have a cell phone, right? The fact that you have that device, the fact that you have a personal computer, the fact of anything with an integrated circuit, it all relies on this fancy math of quantum mechanics that allows us to manipulate electrons to make them go through these tiny microscopic circuits. So these ideas are not just mad math, they're not just weird and abstract insights into the way the world works, they actually have a way of infiltrating our everyday lives. So I think that makes it clear that these do matter, regardless of whether the person with the cell phone understands Schrodinger's equation, it really does matter. And in time, I think the barriers between those who understand these ideas and those who don't will again lower, because over time, ideas that seem impenetrable to one generation become second nature to the next.
Last question.
Well, thank you very much for being here tonight. I had the privilege of asking this question to John Mather and Neil Tyson, so now it's your turn. Would you be willing to speculate on what happened in the moments before the Big Bang?
I would, but I think the key thing to bear in mind is the question may not have any meaning, right? So it could be the case that time itself came into existence with the Big Bang itself, right? the analogy that we love to use is, it makes sense if you're walking on planet Earth to say, hey, can you point me in the northward direction? And you walk further north. You pass somebody else and say, which way from here is north? And they point you in the northward direction. When you get to the North Pole and you say to somebody there, how do I go further north? They look at you kind of quizzically and say, you can't go further north than the North Pole. Here's where north begins. So it may make sense similarly to talk about 10 years ago or 1 billion years ago or 13 billion years ago. But when you get right back to the Big Bang itself, the notion of an earlier time may have as little meaning as going further north than the North Pole. Now, having said that, it may be that there is a time before the Big Bang. These are deep questions that we don't know the full answer to. And there are theories that envision that our Big Bang is simply an interesting and important moment for our realm, but it may not even be a unique event. There may be many Big Bangs, going back to this idea of many universes, and these other Big Bangs in some sense exist outside of our time. So in that sense, there could be a whole reality out there populated by expanding realms, perhaps similar to ours, some very different, in which physics is playing itself out in one environment or another. So that would be not only the notion of before the Big Bang, it would be outside of the Big Bang.
I wonder if there's a tension here between what I believe is just...
Hey, what did Neil say on that one?
Sorry, I wonder that too, but we don't have time. You can ask later. I'm just thinking about a recent conversation I had with Martin Ruth, who was an astronomer, I believe. He says something very clearly, but I think this also is in your work. I think this is a common assumption that as complex as black holes are, and everything that we can know about the cosmos, we, living beings, are the most complex creatures we know of by far. And there's a way in which when you describe kind of how thick we are in not being able to, so that somehow makes us sound rudimentary when in fact we are still the biggest mystery.
Oh, I would absolutely agree with that. The reason we physicists work on the problems that we do is really because they are incredibly simple, right? So we've done a very good job at understanding the electron. We've done a very good job at understanding simple atomic elements. The mathematics behind them is really well understood. But I think the way to organize your perception of the landscape of reality is to imagine that you've got things that are very small and very big. You've got things that are very light or very heavy. And those two extremes take you to quantum mechanics for the very small, general relativity for the very big. But you also have another axis, which is going from very simple to very complex. Mm-hmm. And we are far out on that axis. So we are these complicated collections of particles, and it is very hard to understand such a complex system. So we are very, very far away from being able to write down an equation, if you will, that would allow us to understand what you're going to say next, or predict what you're going to say next. But that, to my mind and to many other physicists, is simply a matter of in practice versus in principle. If the laws of physics are as we understand them, and this may change, I always qualify that by saying that there are things we don't know, like the quantum measurement, there are mysteries, so don't get me wrong. But if there's no qualitative change to the way the laws of physics operate, then your actions, however complex they might be to understand in detail, are governed by the same laws that govern the hydrogen atom. And from that perspective, we do understand you fundamentally, even though we can't make the kinds of predictions that we can about simple systems like electrons and simple atoms.
So Einstein said that he had a cosmic religious sensibility that was about wonder and awe and a sense of mystery, and that was enough. Right? Tell me, do you have a cosmic religious sensibility, or is that a phrase that resonates with you, or how would you describe that?
Yeah, well, again, it all depends on what these words mean.
Right, right.
But, so without labeling
So
it.
what words would you use?
Yes,
for
without
yourself?
labeling it, I would just describe it as I have a deep sense of the amazing harmony of the way the universe is put together. That with these very simple mathematical laws that really can be written down on a T-shirt, which is not a popular. I mean, my kids have such a T-shirt, right? They wear it sometimes. Using those laws, we can understand really how the universe evolved from a split second after the beginning. Big Bang is still a mystery, but we can understand how it evolved from a split second after the beginning, more or less till today, and understand its gross detailed features pretty well. That's an amazing thing. That is spiritual to me. The fact that all this complexity in the world out there can be reduced to a few simple ideas. The power of the math, to me, is almost a spiritual experience. So yes, I would say if that is a good definition of what is religious, then I'm very religious.
You mentioned your kids, and I'm just imagining how handy it would be for them to tell you that they had no choice to do what they did.
They do. You're right. They never get punished. But I had no choice to punish them.
I just wanted, just following on that idea of the spiritual sensibility. Another idea, image that Einstein used was of a mind or an intelligence behind the universe, by which he did not necessarily mean a creator God, but especially with regard to this matter of hiddenness and this thing we've been circling around the whole time, that what you know to be the nature of reality is not something we can perceive in the thick of experience, which is all we have. So if you think about, and I don't know if this is a useful term for you, but if you think about a mind or an intelligence or even that order behind the universe, then how do you imagine that? And also as something that incorporates hiddenness as a way of making its point.
Yeah, so, I mean, there is some debate as to what Einstein really meant by all these wonderful quotes, that some of which he never even said. But I think the important thing to bear in mind, I think many physicists have this perspective, we don't envision that there's some mind behind it all, but we
Right,
do.
no, yeah.
But I would say that we do envision that there are these powerful laws that can do things that you wouldn't expect them able to do based upon the most naive look at the equations. I mean, how could it be that general relativity, the simple equation, and quantum mechanics, and standard model of particle physics, if we put that into the mix, over the course of billions of years, can somehow conspire to yield you and me, this complex, cognizant being? How could we really just emerge from the laws of physics acting through evolutionary change? But that's the power of the math. So if you want, there is the hidden hand. Call it the hidden hand of God if you want. I would simply call it the hidden hand of the equations. And that gets us from the beginning to here.
Okay, I think that's your last word. Thank you, Brian Greene. Thank you all
My
for
pleasure.
coming.